Next operation, filtration or filtering and cold stabilization. There are many different kinds of filters. This is a stack of filters, and the wine is pushed through all of these filtration plates under pressure. And you do have to use the correct kind of filtration for the situation. Different winemakers have different types of filters. And if you filter something out, you got to be careful. You don't want to over filter some things because you might remove important flavor components. And you don't want to under filter because you might leave sediment or things that are undesirable in the wine as well. And this is especially true with the whites. I've mentioned that already. The red wines, if they're cloudy, how the heck would you know? A red wine is not clear. You can't see through it, but a white wine needs to be clear, crisp, bright color. And the cold stabilization process on a white wine helps make sure that you stabilize the chemicals that make up the wine, and you don't end up with a situation where these chemicals can bind together and form a precipitate or solids and make some kind of a residue. It can make the wine cloudy, even though it wasn't cloudy before. All of a sudden, because of some chemical reaction that occurs in an unstabilized wine, the chemical reaction can cause cloudiness or residue that will be undesirable to the wine. The bottling, I think that's pretty self-explanatory. You need a way to make sure you have clean bottles. You need to fill them with the wine in an efficient process. Some small wineries don't have their own bottling, and so they'll make their wine and then send it in a large tank or truck to a bottler that will finish it off with the bottle, label it, and cork it. And you have to make a decision about what kind of cork you're going to use as well. Am I going to use a natural cork pressed into the top of the bottle using natural cork oak tree corks? When you know there is always a failure rate as high as 10% of corks don't do a good job and you get failure. And a lot of people don't know what a failed cork does to the wine, so they just go, wow, this is kind of a funky bottle. I don't like this one. And they don't realize they're drinking a wine that has some oxidation or other problem because of a bad cork, and so they just had a bad experience because of the cork. Do you want to use a screw cap? Screw caps are actually really good these days, especially for wines that aren't going to be aged a very long time, wines that are considered consumable now or very soon. So in the supermarket, actually a screw cap or a synthetic cork is not a bad choice. There's a psychological negative impact on the marketing of a screw cap. It's seen as a lower quality product. Or a synthetic cork, which is just something that looks kind of plasticky, but it has a lot of engineering and experimentation. A lot of money's been put into how do we develop this material that's artificial cork. Percentage of success is much higher, but they're not as perfect as when you have an ideal natural cork. But the only difference is for very long storage and aging of wines for many years. In the shorter term, the few years or less, these synthetics work really good, or screw caps. And even with some of the wines, you don't want to keep it a few years if it's a white wine for sure. And a lot of red wines, they're sold at their optimum flavor. They're not going to get better. They might just slightly get worse. So not all wines are intended to be aged, and white wines are not intended to be aged for a long period of time at all. You buy it, you drink it. And that doesn't mean it has to be immediate, but you don't hold on to it for too long. Harvest decisions. How do we determine ripeness? Well, there's a couple of things. Moisture content, sugar content, and acidity are some of the most important, but they'll sample the grapes in the vineyard, go out there and take some berry samples. They'll evaluate the berries for their growth and maturity. They'll look at the sugar concentration in the juice of the berries. You can either crush some berries and take the juice from a cluster, or you can take an individual berry and put it right on the lens of a refractometer and measure one berry at a time and just go through and measure several berries at different points around the block and get a good idea of how that block is going. But you do need to bring samples into the lab because you're not going to be doing titratable acidity in the field. That's something where the samples are brought into a lab. And while they're taken in a lab anyway, they're going to look at Brix in the lab as well. But titratable acidity is a buffering capacity. How much resistance to change in pH can you measure in the juice? And it's related to pH. pH is a snapshot. What is the acid level right now in that berry juice? That's the pH. How acidic is it right now? But that doesn't tell me everything about the potential acidity and buffering of that berry. If I add a base to try to raise the pH, how much titratable acidity, or what's called alkalinity in some situations, how much buffering capacity or resistance to move up that pH to break the acids or to overcome the acids. And so that buffer, that resistance to change of pH, is an important component of the overall pH profile or acid profile of the grape. So you look at the actual pH, what is the acidity right now, and how resistant is that juice to pH change, the titratable acidity. And there's a very simple experiment to measure titration or titratable acidity. And in laboratories that do this, they can run samples fairly quickly. So the sampling, you certainly have to sample in a way that's going to represent the entire vineyard. So you need to look at places with different topography, different soils. You need to sample different areas. How much do you bulk those samples together? And how much do you keep them apart? Well, the more you bulk them together, the faster you can get your average in a lab. The more you keep them apart, the more time it's going to take, the more money you're going to spend on testing. But if you have problems and you know that one corner of a block is one situation, another corner is another situation, and you know you've got problems, you can measure those problems by keeping the sampling separate. But ideally, you think of your blocks as harvest units, as irrigation units. A block kind of goes together. They're a team, a cohort, a group. And at harvest time, ideally, you don't want to harvest this part of a block on one day and that part of a block on another. So it's often the case, usually the case, where you treat a block as a single unit and you'll get an average for that unit and you'll do your best at harvest. But in some situations, you might want to do that, split the block in half, or in 1/3, 2/3, whatever it takes, because of some differences that you're aware of in topography, soil, whatever, that makes it not uniform. Everything must be chosen randomly. So when you're going through, there are procedures for sampling. So you're sampling different areas of the cluster, different canopy locations up and down, left and right, different distances in the canopy from the trunk. So near the trunk, further down the cordon, away from the trunk. If you've got north-south facing rows, you got to take some off the east side and some off the west side. If I've got east-west rows, I need to take some off the north side of the row and some off the south side of the road, etc. But you don't want to try to do it systematically. If you try to do it systematically, we automatically impose our own bias without even knowing. And so there are procedures for making sure it's random, and we don't accidentally bias the results by doing it the right way that we know. Random is very important. You're going to sample 100 to 200 berries for a good sample. You got to be meticulous in the process of selecting those berries and unbiased in your sampling. And there are tricks that you got to think about. If I'm hand harvesting that, would my random sample include berries on a cluster that I know the hand harvesters are going to pass by? No, I wouldn't include that because I know it's going to end up discarded. There's something wrong with that cluster, and no trained hand harvester is going to take that cluster. So I'm not going to sample that cluster. But if it's being machine harvested, it's taking everything. So I sample all the clusters. If it randomly shows up, I take it. If you're doing cluster samples rather than individual berries, you'll take 20 to 50 whole clusters. Certainly it removes the bias in the individual berry sampling, but again, you have to think about how this is going to impact your operations. You're taking a lot more. 20 to 50 clusters is a hell of a lot more than 100 to 200 berries. 50 clusters, that would mean there's only 4 berries per cluster to get 200. No, there's way more than 4. So you're using more fruit. Is that what you want to do? There are huge advantages to doing whole cluster sampling, but you're handling and wasting more fruit. Vine sample, you basically randomly select a vine and you take everything off of that vine. You just sacrifice a vine, take all of its fruit and bring it in. It's quick, it's easy, it doesn't require going all over the block to sample, but it only is okay to do that when you have an extremely uniform, basically flat vineyard with vines that all look like soldiers. There's no variation going on. That happens. I mean, vine sampling is fine, but you have to make sure that you have a vineyard, a block that is appropriate for it, that a vine sampling will give you representation that is like the rest of the block. Your vine is completely representative. Berry sampling is certainly the most robust, but it is a more tedious process and more subject to human error if you don't do it right. Berry expansion during ripening, we've already talked about this a little bit. Stage 1, rapid growth. Stage 2 is the lag phase. Stage 3, you get the ripening process, resumed growth and maturation or ripening of the berry. And so there's that double sigmoid curve. You get the rapid growth following, which is kind of an S. It starts to speed up rapidly and then it slows down. Then you hit lag phase and then it does the same thing, another S. It starts to speed up and then slow down at the end at maturity. So it's like an S on top of an S that forms this pattern, which kind of goes up and over, then up and over as a double sigmoid or double S pattern. We've seen that already. During ripening, the berry is expanding 3 to 4 times the number of cells. The cell volume or the size of cells grows 300-fold in total volume. Tremendous expansion from the early berries to a fully mature berry. At veraison, you start to get softening. You start to get the coloration. If it's a red berry, there is a color change in the white berries, which aren't really white. You know what a white wine berry looks like. It's more like a Thompson seedless color, that greenish, pale color that we call white in terms of grapes. And this begins at the beginning of stage 3. At the end of the lag phase is when we get the veraison, the transition. So the end of lag phase, the beginning of the stage 3 is when we get that softening, coloration for the reds, rapid increase in sugars, decrease in acids, etc. So here's that double S. Now it's not a really strong S, but you can see an S here in the bottom, really stretched out S with the rapid growth in phase 1. Then you get the lag phase where it slows down. Then you get a second S. Here's that second S going from lag phase, veraison kicks in right here, and you go into a second growth and maturation phase. Sugar and organic acids are the main components, the main things we're looking at in wine grapes, even though there's lots of other things that are important. The sugar is feeding the yeast to turn into alcohol. Most of the sugar is going to be gone, if not all of the sugar. Most wines, all of the sugar is consumed. There's no sugar left, or almost no sugar left when you have a finished product. It's alcohol, not sugar. There are some wine styles where you leave some of that sugar. You start with a very high sugar grape, and it's primarily for the production of dessert wines where you have some residual sugar left over and a high alcohol content. The sugar and the acids have sweet and sour flavors, but very, very little sugar is still there in most wines, if any at all. And so if you have used up absolutely all of the sugar, you would call that a dry wine. You don't have any of the residual sweetness. As a grape ripens, it accumulates sugar. Rapid sugar accumulation starts at veraison, the end of lag phase, beginning of phase 3. The organic acids decline during ripening, and the decline is due to dilution. Remember, those cells are getting bigger. You're not making more acids. So as the cells are getting bigger, 300 times the volume in size over the course of the growth of that grape, you're diluting with more stuff. The acids are being diluted in more cytoplasm. In addition, there's some respiration going on where some of the acids are actually burned by the process, the activity of these living cells, these developing grape cells. And so they're, by the processes of dilution and respiration, acids are going down as sugars are going up. Certainly climate and variety will have a huge impact on the changes in sugar level and organic acids. In general, with all varieties, this pattern is generally the same, although the exact result isn't the same, but the general pattern. Hot climate, you get higher sugars, lower acid. Cooler climate, you get lower sugar, higher acid. And you have to take this into consideration when you are looking at turning that wine grape into a finished product. If you're growing in a warmer climate, something like Lodi, for example, Lodi in the Central Valley, they've got some wonderful wine grapes that come out of Lodi, and they're going to be a higher sugar, lower acid wine that you get from that, or grape anyway, I should say. And so if you're starting with a higher sugar, lower acid wine, you need to take that into consideration with how you're going to turn it into wine. What is the recipe, the process you're going to choose? Some of the areas around here, we certainly have both hotter and cooler climates depending on the microclimate of the individual appellations in Monterey County. Some of the South County ones are pretty warm, and some of the ones like the Monterey appellation tends to be cooler. It gets the influence coming right down the valley of that cooler air shooting down the valley, and so we tend to have a cooler average climate in the Monterey appellation as opposed to some of the ones in the hills or whatever, hidden from or sheltered from the ocean cooling effect that comes shooting right down the valley, blasting through Soledad with the high winds that we get in the narrow part of the Soledad Venturi effect. Anyway, here you see ripening, and we're looking at the soluble solids level, or the degrees Brix, the amount of sugar primarily. Acids do play a role in soluble solids, but with grapes, the sugars are so high that the acids are overwhelmed in terms of the Brix reading. And here we see the titratable acid level. And so the soluble solids, the open circles, measured mostly dominated by sugar. You can see sugars going up, 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 up. And the filled circles, you can see the acidity. There's a little bit of rise in acidity going up still until veraison, and then the acidity drops fairly dramatically after veraison. So this is just a graph illustrating what I've said numerous times. Sugar measurement, again, nothing new. Sugars are glucose and fructose. Fructose being a sweeter taste, but the combination are the most important flavor components of the grape sweetness. There are other berry constituents that are synthesized directly from glucose and fructose. Sugars are the starting molecule for many things. Abundance allows indirect methodology for measurement because there are so high sugars and they so dominate the liquid that we don't have to worry about acid levels. Even though acids are important, they really have a small influence on soluble solids compared to something like a tomato, where a tomato does measure sugars in the, or excuse me, degrees Brix in a tomato is measuring sugars, but it also is measuring acids because a tomato isn't nearly as sweet as a grape. But because of that, we can get in a very close approximation where for every unit of Brix, every number is 100 grams per milliliter of sugar. So if I have a berry at 100, or excuse me, at 16 degrees Brix, I have 16 grams of sugar per 100 milliliters of juice. Is that what Brix means? Not really. It just happens that it works when you have a high sugar situation like grapes. You can't convert Brix like that in other commodities. It doesn't work if I'm dealing with tomatoes or celery stalks or cantaloupes maybe. Cantaloupes actually are sweet enough where I think the number would work, but grapes definitely. There's so much sugar that we have this really easy, consistent conversion. Oops. A hydrometer used in winery to monitor fermentation. And what is a hydrometer? A hydrometer is a device that floats in liquid, and it has a little stem on the top, and the denser the liquid is, the more dense the fermentation solution, the wine juice, the higher it floats. Kind of like a boat in the ocean floats a little bit higher because the salt water is more dense than fresh water. So if I take a boat and I'm out in the ocean, I'm going to float a little higher, but I go into less dense water, like a lake, a freshwater lake, I'm going to float a little bit further in. I'm going to sink a little bit down because fresh water isn't as dense. Well, guess what? Alcohol is less dense than water. So if I have this hydrometer and I put it in pure water, it's going to float at one level. But if I put it in grape juice, unfermented, all of those sugars and other things in the grape juice, the hydrometer initially floats a little higher. There's a lot of water in grape juice, but there's also a lot of sugar, and that pushes it up. So I start at the beginning. I measure my hydrometer reading. How dense is my grape juice? And then as it's fermenting, the sugars are being used up. So the sugar level's going down, and it's being converted to alcohol, which is not a dissolved solid, it's a liquid. And alcohol is less dense than water. So over the fermentation, my hydrometer is sinking. So every time I measure it, every day I go out there and I measure it, the hydrometer is measuring a little further down. It's sinking, sinking, sinking every day as the sugar is converted to alcohol. And so again, I can use Archimedes' principle by floating the hydrometer device and just measuring this little stem, how much is sticking out. The more it sinks, the less of the stem is sticking out of the top of my fermenting juice, and I can calculate how far along my fermentation has proceeded. It's a relatively quick and easy calculation to do, but it's a very important principle for helping to understand and monitor how far your fermentation has gone. There's also the refractometer that's used in vineyards or in the lab, and it is a refractive index to measure sugars, and the refractometer is just the device that we've already talked about that measures degrees Brix. And I need to take another short break to keep these in manageable chunks. I'll be right back.